Good morning, students. So, in my previous class, I have discussed about Thales theorem. So, there are some other formulas related to this Thales theorem what we will be using to solve the examples in the exercise. So, I will be discussing regarding them now. So, these formulas they have not given in the textbook. So, please make a note of them in your notes. So, what I am writing on the board. So the name of these formulas they are called as corollaries. So let me take the triangle that is triangle A, B and C, where B is parallel to BC. So according to your Thales theorem, so the ratio is AD upon BD, that is equal to A upon that is EC. So the first corollary, so I am going to take the ratio and add 1 to it. So A upon EC, even for this also add 1 to it. So take the LCM here. So here the LCM is DB and here it is EC. So let us write down AD plus DD upon DB, that is equal to AE plus EC upon EC. So AD plus DD is equal to AD upon DD, that is equal to AE plus EC is equal to AC upon EC. So if people are supposed to write only this formula, you did not write the whole thing. Then coming to the second one, I'll reverse this ratio, that is DD upon AD, that is equal to EC upon AD. Even for this also, let me add one. So here the LCM is that is 80. So multiply this by 80 and this by that is your 80. So 80 plus 80, that is equal to EC plus AE upon that is 80. Then what you are going to get? 80 plus 80 is, I am sorry, it is dB plus AD. So dB plus AD gives you, that is your AD upon AD. So that is equal to, this gives AC upon that is AD. So this is your second corollary. So one more is there, the third one. So let me write down here. So let us compare here. So this parallel line divides this big triangle into one small triangle as well as one big triangle. So how to take the ratio? So let us take the ratio of a small triangle, that is AD upon AD, that is equal to AE upon that is AC, and that is equal to V upon that is PC. So this is the third formula or even your third corollary. So which I am going to use to solve the example. So students who are writing these into the heading as corollaries and write the first one, second as well as the third formulas. So now let me start with the exercise. So I am going to start with the exercise, that is exercise 2.2. So the first one is very easy. So let me go for the second. 1.8 and the value of that is EC is 5.4. So in both the numbers, the decimal point is after one place. You can just skip the decimal point. So let me cancel it. I'll cancel by 9. So 9 2 and 9 6 times. 2 1 time and 2 3 times. So let us cross multiply. So 3x is equal to 7.2. Then x is equal to 7.2 upon 3. So cancel it. So 2 times and 4. So my answer is 2.4 centimeter. So which can be asked in the examination for either 1 or even for 2 marks. So let me come for the second example, students. So here diagram is not been given, but this is not only for that is 1 mark. They have given all the measurements. You have to check whether the line is parallel or not. So let me draw a rough diagram for this. They have given that is in the angle P, Q and R. So here EF. So it's a line given. We need to check it out whether it is parallel or no. So the measurement what I have given, the measurement of P is 3.9 centimeter and the measurement of EQ is 3 centimeters and the measurement of PF is 3.6 centimeters and the measurement of PF is that is 2.4 centimeters. So let us take the ratio. So that is by BPT or K7, that is PE upon EQ, that is equal to PF upon that is FR. So let us put the value. The value of PE is 3.9 centimeters and this is 3 centimeters and the value of PF is 3.6 centimeters and this one is 2.4 centimeters. Let us cancel it. So 3 1 time 1 and 3. So let me cancel by 12 table. So 12 3 times. So you can clearly see here the ratios are not equal. So that is by converse of that is BPT. So here we can say that EF is not parallel to that is your QR. So this is how we need to put the values and check. So according to the converse of BPT, if the ratios are equal, then only the line is said to be parallel to the third side. So second you can try, student. Let me go for the third example. So let me draw here also a rough diagram. That is triangle P, Q and R, P and L. So they have given the value of the whole PQ is 1.28 centimeters. The value of that is PR is 2.56 centimeters. The value of P is 0.18 and the value of PF is 0.36. So earlier students we had the measurement of that is 2 half sides, but here what I have given is, so if I take PQR as a big triangle and PEF as a small triangle, so they have given the bigger side as well as the smaller side. So here we can't use DPT. So according to how I have proved the corollaries, so let me take the corollaries and try Pf upon that is Pr. So let us write the value of P. So the value of P here is 0.18 and the value of that is Pr is 1.28. So Pf is 0.36 and value of this is 2. That is 56. So here after two decimal places the point is you can cancel that. So let me cancel this by 2 times table. So it is 0.8. You can take it as 18 or let me write down once again. So 18 upon 128 that is equal to 56 upon 256. So 2 9 times and 2 64 times. Let me cancel this by 4 9 times and here also 64 times. So here it is very clear that both the ratios are equal. So therefore by that is converse of your BPT. So here EF is parallel to that is your QR. Students, let me take one more example and conclude. So the last example, that is let me take the third example here. Diagram has been given. So it is A, M, and this sum comes in the exam. This is for 2 marks. Here LM is parallel to that is BC and LN is parallel to that is your BC. So now what has to be proved, let us write out. So here we need to prove that AM upon that is AB is equal to AM upon that is AB. So how to prove this? Students, here we can see the first triangle, that is triangle BAC, the other triangle, that is ABC. So here LN is parallel to BC and LN is parallel to that is CD. So let us take the triangle separately and try out. So first I take in triangle that is BAC, LM is parallel to that is BC. So here I can't use just BPT. So again it is by corollary of BPT, that is AM upon AB that is equal to AN upon AC. So let me name this as equation 1. Then one more triangle, that is in triangle DAC. So here LN is parallel to that is your CD. So again by that is your corollary. So let us write down. So you wrote again that is AN upon AD is equal to AN upon AC. So this is my equation 2 by comparing equation 1 and 2. So here these both are equal, so therefore even AM upon AB is equal to AN upon. So that is from 1 and 2 we can conclude that AM upon that is AB is equal to AN upon